Good evening. Today, my team and I will provide a brief description of the project we worked on and further elaborate on the work that went into it. We are required to design a 5-story residential building with the focus being mainly on two-way slabs. I will provide a quick introduction of the work, whereas my team members will provide more detailed information. As you can see, the image here shows the architectural plan that my team and I chose to represent all the floors in our building. The main objective of this project and the new project-based learning system, by extension, is to create a project that encompasses all the requirements needed for the course. This is done by splitting up the work into several key elements: slabs, beams, columns, and foundations. We will start by choosing an architectural plan and then converting it into the structural plan that you see here. Then 3 different categories of slabs will be analyzed. Flat plate, where the entire slab is one thickness and there will be no internal beams or drop panels. And in this system, the thickness is expected to be the highest between the 3 slab systems to account for the punching shear. Next is the flat slab, which is similar to the flat plate system. However, the slab is expected to be much smaller in thickness, since drop panels will be provided in the places where punching shear test is found to be unsafe. Finally is the solid slab system, and this is the most common system used in construction, and it includes internal beams and it does not have any drop panels. After deciding on the thickness, the design for the beams is conducted for the solid slab system, as it has internal and external beams as well as the edge beams. Furthermore, there are edge beams in the flat plate and the flat slab system, which will be designed as well. Next is the columns, and this step has 4 major elements. The first is grouping the columns, thus making design easier. The second is checking for the slenderness ratio, and we do expect that they will all be short columns, as the floor-to-floor height is no more than 3 meters. The third step is using safe software to provide the loads on the columns. And finally, using those numbers we obtained from SAFE, we will follow a straightforward procedure to obtain the dimensions and steel reinforcement needed. Last but not least, for the design of the building is the foundation. There will be 2 different systems of foundation: isolated footings and combined footings. Now, the way the work was split up amongst the team members was as follows. The entire group was split into 3 smaller subgroups. Each one of these 3 subgroups contains 2 students. Now, each subgroup is responsible for the entire design of one whole system. For example, the subgroup 1 will be responsible for the design of the slab, the beams, columns, and foundations only for the flat plate. This way, each student will be exposed to all the content and all the material will be double-checked before being finalized. Now, we will begin with the flat slab. Me and my colleague, Al-Hassan Mahmoud, were in charge of this system. The main distinction of the flat slab system is that it does not rely on beams. Rather, the weight of the slab is transferred directly to the columns. However, if the punching shear check was found to be unsafe, a drop panel is provided, as you can see in the 3D picture. The drop panel is provided to prevent the punching shear and to make it safe. Moreover, this will help us in decreasing the thickness of the slab, thus reducing the concrete volume requirements. And finally, my colleague Hassan will take you through the detailed information regarding the design of the elements for the flat slab. Thank you very much.